Hi, my name is Nageshwar Rao, faculty in the ISRO Engineering Academy. So, I am going to discuss the previous ISRO questions. As I observed, the ISRO questions are easy as compared to the GATE questions. And GATE syllabus and ISRO syllabus both is same, no difference. Who are preparing for the GATE, it is very easy to clear the ISRO questions because here calculator not allowed, so the questions are very easy. So, come to the questions. First one, a ramp input applied to the unity feedback system results 5% steady state error. So, steady state error is 5%, means it is constant. Constant steady state error for unit ramp input. Unit ramp input is possible only to the type 1 system. To the only type 1 system. That means the type of the system should be 1. And we require to find the zero frequency gain. Zero frequency gain means constant. KV you have to find it. The steady state error for ramp input is A by KV. So 5% means 0.05 equal to 1 by K. So KV is nothing but K. So find the K value. K equal to 1 by 0.05. That means you will get 20. So the answer is A, 1 and 20. Next, second question. So this is previous GATE question only. So the magnitude of frequency response of underdamped second order system is 5 at 0 radians per second, peaks 10 by root 3 here, 5 root 2. The transfer function of the system is, so that means what is the information given here? At omega 0, the magnitude is 5 given. So this is the magnitude, they given 5. And at resonant peak, at resonant frequency, what is the resonant frequency given? 5 root 2. The magnitude given is 10 divided by root 3, the given magnitude. 10 divided by root 3, the given magnitude. They are asking transfer function. So first we can use MR. MR equal to K. K is a magnitude at omega 0 divided by 2 zeta root of 1 minus zeta square. So MR is 10 by root 3 equal to K is 5. Magnitude at omega 0 is 5 divided by 2 zeta root of 1 minus zeta square. Now solve for zeta. If you solve for zeta, you will get zeta is 0.5 and 0.866. So it is invalid, this is valid. Then because for resonant peak, the zeta must be 0.707. So that means 0.5 valid. Again given omega R. Omega R is 5 root 2 equal to omega n into root of 1 minus 2 zeta square. Then 5 root 2 equal to omega n into root of 1 minus 2 into zeta square, 0.5 square. You solve this equation, omega n become 10 radians per second. Omega n become 10 radians per second. So then simply what is the transfer function? Equal to K into omega n square divided by S square plus 2 zeta omega ns plus omega n square. So then you substitute K, omega n 10 means 500 divided by S square plus, you will get here 10s plus 100. This is the answer. So that means the answer is A. So they can go by even other way also. We want at omega 0 magnitude 5. You substitute S0. In which option you are getting magnitude 5 we can observe. Then we can check the zeta. So zeta and then we can find MR. We can check the MR value. Reverse also can go from the options. Okay. Next question. So this one, the system with open loop transfer function given as the gain margin of they are asking. Simply we can go by two methods. Method 1 is by procedure, that is gain margin equal to minus 20 log of magnitude of G H of j omega at omega equal to omega PC, one method. Or method 2, we can use RH criteria. RH criteria as I discussed in the class. Simply best is method 2. Here you have to find omega PC. How to find omega PC? Angle GH equal to minus 180, how to use minus 180 equal to minus 90, angle GH right, minus tan inverse of imaginary part by real part. What is imaginary part? Omega divided by 1 minus omega square. Yes, replace by j omega and check it. Then if you solve, all minus become plus, then 90 equal to tan inverse of omega divided by 1 minus omega square. You solve this, you will get omega is 1 radian per second. You find magnitude at omega 1, you will get it 1 only. Gain margin becomes 0 dB. But instead of solving like this, simple logic, characteristic equation you write S cube plus S square plus S plus 1. Internal product 1, external product 1, marginal stable, marginal stable, marginal stable, marginal stable means gain margin is 0 dB. Simply it is 0. So best is RH criteria. Next here they are asking Kp, Kp, Ki, Kd values. 3 parameters are there. Here roots at minus 10 zeta given data. Simple logic here also. You can write the characteristic equation by using PID controller, and then we can substitute option A, option B, option C. We can check this given data. That is the best way. But as per procedure means, first for given data, write the characteristic equation. What is the characteristic equation? One pole at where? Minus 10 means S plus 10. For remain, zeta should be 0.8 means S square plus 2 into zeta 0.8 into omega n 2 S plus omega n square 4 equal to 0. You expand this. If you expand this, 1 minute. You expand this, then if you expand this, you will get S cube plus 13.2 S square plus 36 S plus 40 equal to 0. This is equation number 1. Then again, from the function, from the block diagram, write the characteristic equation. What is G of S tell here? What is G of S? 4 divided by S square plus 6S plus 1 into PID controller. PID controller transfer function Kp plus Ki by S plus Kd S. This. So if expand this, what I will get? 4 into Kd S square plus Kp S plus Ki divided by S into S square plus 6S plus 1. So this is G of S. Characteristic equation means what? 1 plus G of S equal to 0. If you write the characteristic equation here, so what is the characteristic equation? You will get expand, final value I am writing, final equation S cube plus S square into 6 plus 4 Kd plus S into 1 plus 4 Kp plus 4 Ki equal to 0. This is equation number 2. Now compare equation 1 and 2. Compare it. If you compare 1 and 2. Just no need to compare all. Easiest factor you compare 1 and 2. So which is easiest factor? You can see here 40 equal to 4 Ki. 40 equal to 4 Ki. Then Ki equal to what? 10. You observe the option. So in 10 option there is only one, that is option A. 10 is there, Ki equal to 10 in only option A. So that means option A is correct. Similarly, you want to compare. You compare S square terms. If you compare S square terms, 6 plus 4 Kd equal to what? 13.2. Like this, compare and solve. Again, you can solve it what? You can compare. Next, you can compare what? S terms. So then you can get the answers. Okay? Next question. So they given a transfer function. Which network they are asking? Simply identify the poles and zero location. What is the location of pole? -1. What is the location of 0? -2. That means the location of 0 is the location of 0. The location of 0 is -2. That means it is a what? Lag compensator. So answer is A. Next, the signal flow graph of certain feedback control system is given. Which of the equations are correct? They are asking. Simply x2. So you observe here at x2. So how many incoming branches are there? You observe to the x2. One is from x1 is there. Next x3 is there. So that means a1 x1. So a1 x1. Then a9 x3. That means this is correct. Next again x3 to this. How many incoming branches? One is from x2, one is from x4. Two terms is there. Two incoming branches mean two terms. So that means a2 x2. This is capped here x2. This is x2 plus a8 x4. This is x4. That means this is also correct. Next x4. This is the year. How many incoming branches here you observe? There are three incoming branches are there here. One is this. So that means a3 x3, a3 x3. Second one, another incoming branch from this a5 x2, and one more incoming branch is there. Here also one incoming branch, and here also one incoming branch. Three incoming branches are there, but here only two terms are there. That means this third is wrong. One term missing. Fourth one x5. Here you observe x5. How many incoming? Two. So a4 x4 correct. This is x4. And then a6 x2, a2 x2. So this is correct. That means answer is 1 to 4. Next, the system with the transfer function given as an output for an input. This is also previous gate question. Most of the questions I observed, they are directly giving the previous gate questions. You can observe it, all these questions, most of the questions. So here we already solved this question in the class also. So here what you have to do? Omega given 2. Omega given 2. S replaced by j omega. So that means j2. So y of j2 by x of j2. Write the magnitude and phase and compare. You will get the answer. So that means j2 divided by j2 plus p. If write the magnitude here, 2 by root of 4 plus p square. And if write the phase pi by 2 minus tan inverse of 2 by p, minus tan inverse of 2 by p. Now write the output, compare with the given output. So what is the output? Y of t equal to, here p is there, magnitude is producted, that means 2 divided by root of 4 plus p square, magnitude producted, into cos of phase angle added 2t minus pi by 2 plus pi by 2 minus tan inverse 2 by p, tan inverse 2 by p. So pi by 2 is getting cancelled. So then again, so you compare this, you consider this is equation number 1. This you compare with given output. What is the given output here? Y of t is cos 2t minus pi by 3. Compare phase simply. Compare phase. So if you compare phase here, 2t minus tan inverse of 2 by p equal to 2t minus pi by 3. 2t minus pi by 3. 2t is getting cancelled. 2t cancel, minus minus cancel. Tan inverse, you can compare with magnitude also, same answer you will get. 2 by p equal to 60 degrees pi by 3. Tan 60, 2 by p, tan 60 is root 3. So p equal to what? 2 by root 3. 2 by root 3 is the answer. That means answer is C. Next one. So this is a Bode plot they given. They mentioned, they didn't give the, actually this is also previous gate question only. This is also previous gate question only. In the gate question they didn't mention here 3 zeros, and we have to find the slopes and then you have to write the transfer function. So simply what is the transfer function tell here? So 3 zeros, if I write the transfer function here, if I write the transfer function, so solution, if I write transfer function you write sum k into, here 3 zeros, 3 zeros means 1 plus s by 0.1 whole power 3. Here 2 poles means 1 plus s by 10 whole square. Here 1 pole means 1 plus s by 100. It's the transfer. You have to find the k value. So how to find k? Where you know magnitude? 20 at 0.1. 20 at a frequency of 0.1 equal to simply 20 log k. So k equal to how much you are getting? 10 power 1 means 10. K is 10. Now but this is in the what? Time constant form, but options are given in pole zero form. So adjust it to pole zero form. So what I should write? 10 into, what I can write? LCM you do it. 0.1 plus s divided by 0.1 whole cube divided by 10 plus s by 10 whole square into 100 plus s divided by 100. Now you solve this, what I will get here? 10 into 10 square here into 100 divided by 0.1 whole cube into s plus 0.1 whole cube divided by s plus 10 whole square into s plus 100. Then you solve this, you will get 10 power 8 into, because here 10, 1, here 1, here 3, 4, 5, here again 3, means 10 power 8 into s plus 0.1 whole cube divided by s plus 10 whole square into s plus 100. So answer is A. All these are ECE questions I am discussing first. ISRO ECE. Next. So in the figure, from obtain the state equation. Simply what you have to do, they given here state variables also. Here x2 selected, here x1 selected. So now we have to write the equations of differential state variable. So here what it is? x2 dot. Here what? x1 dot. You write the equation for x2 dot. x2 dot equal to, what is the equation tell? 1 into u, then minus 3 into x2. Minus 3 into x2. Yes or no? 2 incoming branches. Next similarly x1 dot. What is x1 dot we are getting? 4x2. 4x2. Here 4x2 minus 2x1. Minus 2x1. Yes or no? Minus 2x1. Then y equal to what tell? Y equal to 1 into x1. Yes or no? Y equal 1 into x1. So now write the state model. So x1 dot and x2 dot equal to, so A, what is x1 dot? Linked with minus 2 and 4 and here into here x1 x2 plus into here u. So now tell, so here x1 dot 4, x1 minus 2, x2 4, then x2 dot only x2 minus 3, input by here 1, x1 dot not related with input, and what is the answer? minus 2, 4, 0, minus 3, 0, 1. That means answer B is correct. Next one. Next. System has some poles lies on imaginary. Imaginary means we know it is a what? Marginal stable. But they didn't mention repeated or non-repeated. We consider it is a non-repeated because repeated means they will mention. So, marginal stable. Next, this is also previous gate question only actually. Open loop DC gain is asking. What is the transfer function given? S plus 4 by S square plus 7S plus 13. So, this is a closed loop transfer function. But what they are asking? What they are asking? Open loop DC gain they are asking. We require to find open loop DC gain. So, first write unity feedback. Mention unity feedback. Just find open loop transfer function. Simple logic is what? Subtract numerator in the denominator. So, 7S plus 13 minus S minus 4. That means S plus 4 by S square plus 6S plus 9. So, DC gain means simply you put it S equal to frequency 0 for DC. That means answer is 4 by 9. So, answer is C. Next, the impulse response they given is asking steady state output for the unit step. So, simply impulse response given IR. IR equal to e power minus t. What is the transfer function? Laplace of impulse response with all initial condition 0. That means what is the transfer function? 1 by S plus 1. You have to find steady state value for unit step. So, simply steady state value means CSS na equal to limit S tends to 0 S into C of S. So, then limit S tends to 0 S into what is C of S? This is C of S by R of S na. It is nothing but what? C of S by R of S. That means what is C of S? 1 by S plus 1 into R of S. What is R of S? 1 by S. SS cancel. S tends to 0 substitute. What is the answer? 1. So, the answer is 1. Next. So, a system has 14 poles, 2 zeros. 14 poles. We used to discuss these things in the class itself. 2 zeros. Resultant what? 12 poles. 12 poles means what is the slope tell? At high frequency means infinity. At high frequency means infinity. At high frequency means infinity. So, at infinity what is the slope? 12 into minus 20 means minus 240 dB for decade. Minus 240 dB for decade. Next. So, consider a unity feedback system having open loop transfer function. The open loop gain K with the gain margin equal to 20 dB. We want gain margin of 20 dB, we want it. So, what is the formula for gain margin? Gain margin equal to minus 20 log of magnitude of GH at omega PC. And first we need to find omega PC. So, find omega PC. How to find omega PC? Angle GH equal to minus 180. So, minus 180 equal to minus 90 minus tan inverse of 0.2 omega. Yes or no? Minus tan inverse of 0.05 omega. 0.05 omega. Right, sorry. 0.05 omega. Yes or no? 0.05 omega. You solve this, all this will be cancelled. Then 90 equal to tan inverse of, I can write here what? Omega by 2 plus tan inverse of omega by 5 na. This is 5. 5 na. 0.2 means 5. 5. Here I can write omega by 20. Yes or no? So, then you solve it. 90 equal to tan inverse of, you solve it, omega by 5 plus omega by 20 divided by 1 minus omega square by 100. So, tan 90 infinity, solve this. Infinity means denominator 0. then you will get omega PC is 10 radians per second you will get. Then gain margin, you find it, how much you want gain margin? 20 equal to minus 20 log of magnitude of this. So K divided by omega root of, we can write it what? Omega by 5 whole square plus 1. You can write this what? Omega by 20 whole square plus 1. Yes or no? At omega PC. So then this will become 0.1. K divided by, substitute this, 10 root of 10 by 5 whole square plus 1 root of 10 by 20 whole square plus 1. You solve this equation, I think you will get 2.5 will get it. You solve this, you will get the answer is 2.5, I think, 1 minute. Yes, K is 2.5 you will get it. The answer is 2.5. Next. So they given the open loop transfer function of unity feedback, range of K value for stability. Simply we can use RH criteria. So RH criteria it is, RH criteria. So what is the characteristic equation tell? 1 plus G of S equal to 0. If you write characteristic equation, we are getting S power 4 plus 4S cube plus 5S square plus 6S plus K equal to 0. This is the this is 4S cube. So now write the Routh tabular form. Routh array you write S power 4, S cube, S square, S power 1, S power 0. So if you write it here, 1 alternate, 5 alternate, K alternate, K. Next year 4, here alternate 6. Then you solve here, you will get 20 minus 14, 14 by 4. Here you will get K, here you will get K. And then you solve here, you will get 21 minus K. 21 minus K divided by 14 greater than 0, you will get it. 14 which is greater than 0, you solve it. K is what? Less than 4K here, 4K. 4K. K you will get less than 21 by 4. 21 by 4. That means the answer is what? Greater than 0, less than 21 by 4. So the answer is here you are getting A. Next. So here the steady state response of step input. So here X of S given is K by S. To a system whose the transfer function H of S is given. What is H of S? This is input. Input is K by S. X of S given is 1 by S plus 5 into S plus 2 is given. So then what do you want? Steady state response they want it. Steady state, and what is the steady state response means? HSS steady state response. The steady state response they are asking to the transfer function they are giving. So only steady state means at infinity. That means XSS equal to limit S tends to 0 into H of S. We will write H of S. So here HSS will write. So that means limit S tends to 0, S into, what is H of S? This input you have to substitute, na? So K by S into S plus 5 into S plus 2. This is the transfer function. Na? So you have to substitute the input. So input K by S added to this. then SS cancel, S tends to 0 substitute. Then what is the answer? What is the steady state response you are getting? K by 10. Answer is K by 10. Next, so here consider the closed loop stable phase lock loop system shown in figure. The system capable of producing 0 steady state error. We want steady state error should be 0. See, this is the output. This is the output. That means here this is input. That means what it is? Unity feedback. You need to consider this total as G of S. This total is a G of S because here is the output. So that means product all these things, what is G of S tell? K into K1 plus K2 divided by S into 1 by S. Now what is G of S tell here? You solve this G of S. So K into K1 S plus K2 divided by S square. H of S is 1 here. That means it is type 2 system. Type 2 system gives the steady state error for 0 for step as well as ramp. Step, ramp, it gives error is 0. So that means what happened? Phase step correct. But here see both are there. Step is there. Velocity means ramp. That means option B is correct. Next, here they given a pole location response. We know it. The poles lies in the left hand side, underdamped system. Simply A. The question is very easy compared to gate. Here, phase of the transfer function of the circuit they are asking. Simply write the transfer function. V naught of S by VI of S. So here what is the Laplace of capacitor? 1 by SC. So what we are getting? Tell R divided by 1 by SC or R plus 1 by SC. So then write the phase angle pi. Pi equal to angle of R is 0. Simply minus of, because yes or no, minus of tan inverse pole na. So tan inverse of imaginary part by real part. What is imaginary part? 1 by omega c. Yes or no? 1 by omega c divided by real part is R. So that means imaginary part by real part kada minus 1 minute. Yes, correct. So here imaginary part be a denominator R, say R divided by R plus S replaced by j omega 1 by j omega c. But here the j should bring to the numerator na. So that means what I should write? R by R minus 1 by j means become minus j divided by what? Omega c, because you have to write imaginary part by real part. Directly we cannot write. So here we can write in other way also, but based on the option you should, I will write it second method also. So now write the angle. This is which quadrant? Tell fourth quadrant, positive real and negative imaginary. So pi you write it, pi equal to numerator R means constant, so 0 minus of fourth quadrant simply angle minus tan inverse imaginary part by real part. What is imaginary part? 1 by omega c divided by real part is R. So that means what you are getting? Tell. So tan inverse of 1 by omega c R. So that means answer is A. The other way also we can write. What is the other way? R2. But that option is not there. How to write it? Tell other way. V naught of S by Vi of S equal to, what is the answer? You take LCM here. SCR divided by SCR plus 1. So if you write pi here, numerator is S is there, that means 90 degrees. So 90 minus tan inverse of imaginary part means SCR is there, means omega RC divided by 1. This is also correct, but this option is not there. So that's why you have to go by other method. Okay, na? Next, based on the options we should proceed writing the phase angles. The characteristic equation given, and is asking either stable or unstable, and they are asking this. So write the Routh tabular form. So s power 4, s cube, s square, s power 1, s power 0. So then here 3, alternate 5, alternate 2, 3, 5, 2. Next here s cube, 2, alternate here 1. So then solve this. So here 7 by 2, yes or no, 10 minus 3 means 7, 7 by 2, here it is 2, here it is 2, 3.5 minus 4 means 3.5 minus 4 means minus 0.5, minus 1 by 2 divided by this. You solve it, you will get minus 1, negative value will get here, means 2 sign changes, means system is what? Unstable. The given system is unstable. Next year feedback, all these are for ECE I am discussing. So consider the system, value of K for marginal stability, same RH criteria only. So you can solve by yourself simply. So what is the characteristic equation tell? 1 plus GH equal to 0. If write a characteristic equation, so what is GH tell? 1 plus GH equal to K into S plus 4 divided by S into S plus 1 into S plus 2 equal to 0. So what is the characteristic equation we are getting? S cube plus 3S square plus S into K plus 2 plus 4K equal to 0. Internal product 3K plus 6 equal to external product 4K. So solve it here, K equal to how much tell? 6. That means answer B is correct. So they given here Bode plots, which is stable they are asking. We know it simply, here 0. What is this tell? This is nothing but what? 0 means this is omega GC. And this is what? Minus 180 omega PC. That means here omega PC greater than omega GC, the given system is what? Stable. Here what is the question? Consider the Bode plot, they are given two different systems of unity feedback. The open loop poles, open loop transfer, no poles in the right, and it is a minimum phase system. So then it is stable. Here you observe, this is what? What is this? Omega PC. And this is what? Omega GC. That means omega PC less than omega GC. That means it is unstable. That means first one is stable, second one is unstable. First one stable, second one unstable. That means answer A. Next we will discuss the electrical questions. Electrical questions are most of the questions are theory oriented is there. Easy is there. Easy, very easy. Easy little bit problem oriented is there. See electrical questions you observe. What does the transfer function of the system described for? 0 input? No. Yes or no? 0 input response means what? 0 input response due to initial conditions. This is due to initial condition means wrong. 0 state response means this is due to input. So transfer function due to input only will find out, that means answer B is correct. Next, two identical systems have been cascaded non-interactively. The step response of the system will be critical damped, under damped, over damped. Even we discussed in the class also, I taken two electrical networks cascaded, in between insulator I put it. Remember na, the poles are repeated, we discussed in the class also. Critical damped system, yes or no, the system is going to be critical damped. Whenever two identical systems are non-interactive, poles are going to be repeated, it is going to become critical damped. Third one, which of the following method most strong tool to determine the stability and transient? We want stability as well as transient. Stability and transient is possible only in the root locus, because RH criteria, it gives just the stability, either stable or not. Bode plot, it gives gain margin, phase margin. We don't know the pole location. Nyquist also same problem. That means what? All these three are wrong. Root locus, we know the pole's location. We can identify the transient response of the system. Next question. The gain of the critical, if the gain of critical damped system. So that means the system is critical damped. Gain increases. What happened? The system become under damped. For example, you take any critical damped system. So critical damped, for example, 10 divided by 100 divided by s square plus 20s plus 100. That means what happened? Omega n become what? Omega n become 10. 2 zeta omega n becomes what? 2 zeta omega n 20. That means we got zeta is 1 critical damp. Now I will increase the numerator. You will take, for example, you take 160 or you take it 1000, 10,000, like that you take it. That means what? Omega n increases. As omega n increases, it is going to be divided now here. The zeta is going to become less than 1. The system becomes the what? Under damped. Yes or no? You put it is k here, k is going to be divided. So gain increases, zeta is reducing. Okay, na? Next one. The phase margin of the system is specified. Phase margin, generally what happened? It specified the frequency response, but generally it is what? It is a frequency response as well as relative stability. Phase margin, gain margin, all will give the what? Relative stability of the system. It gives the relative, it is a frequency response analysis, but it gives the what? Relative stability. Next. If the poles of the system on imaginary axis, we know it is a what? Marginal stable system. Poles on imaginary means marginal stable. Which one of the following most likely reason for large overshoot in the control? Large overshoot is possible with high gain. K increases, what happened? Tell? The zeta is going to be decreased. The zeta decreases means percentage of MP increases. So that means peak overshoot become very, very large. Large gain always gives the what? Large peak overshoot. Band pass filter. So band pass means what happened? It is the what? Frequency passes between, it is a yes or no? Amplitude passes between two frequency ranges. So passes frequencies between two designed cutoff frequencies. It allows the only certain frequency band. Here, assuming initial conditions, 0 initial conditions, y of t given below, the unit step response. Here this is y. So y by u equal to 1 by s. Then, so again they given what? 1 by s. So 1 by s. And which response? Step response, unit step response, means u is 1 by s. That means y of s become what? 1 by s square. Apply inverse Laplace transform. So simply y of t equal to t into u of t. So the answer is C. Next, the unit step response given, its impulse response. One is differentiation method, second one you can find even transfer function also. Two methods you can do. So if you differentiate it, so impulse response is nothing but what? Differentiation of step response. Step response. Differentiation of step response. You can do it. Differentiation of step response. So d by dt. So if you differentiate, one will become 0. You differentiate this, e power minus alpha t means minus alpha into e power minus alpha t. So minus minus becomes alpha e power minus alpha t. Or you can find a transfer function and inverse, then also you will get the same answer. Bode diagram, you know it is approached for what? Minimum phase network. Because even if we draw a Bode plot for non-minimum, we cannot define the what? Stability, gain margin and gain margin, phase margin concept valid for only minimum phase system. Which one of the following strongest to determine? Already second time again, same thing, root locus. Root locus is best for stability and transient response. This and all already covered. Under damped, na? Gain is increased, under damped. So here it is RH criteria. It is RH criteria. Characteristic equation given. and the closed loop system is they are asking. So you have to write the what? Routh tabular form, and then we have to solve it. So write a Routh tabular form, s power 4, s cube, s square, s power 1, s power 0. You solve this. One minute. Write this. So here what you will get here? 1 alternate 11, alternate 18, next year 2, alternate here 18. Yes or no? Alternate is 18. You solve it here. Here you will get 2, here 18, here 0, 0, 1 time row of 0 you will get. Then here it is 4, here 18. 1 time row of 0 means 2 poles must lies on auxiliary equation if right. Auxiliary equation second order, 2s square plus 18 equal to 0. That means 2 poles must lies on what? Imaginary axis. Next, if the gain of doubled, gain margin become what? Half. Already we discussed in the class also. As the gain is doubled, gain margin becomes the what? Half. This also we discussed. Alpha system, the phase difference is what? Plus or minus 180 degrees. Because alpha system means 0 should be right, poles will be left. The phase difference is exist around plus or minus 180 degrees. On and off controller is a non-linear controller. On and off controller means it is a non-linear. The transfer function of phase lead given, then the maximum phase provided by controller. It is given what? 1 plus 3 tau s divided by 1 plus tau s. I told the transfer function for compensator is 2 models I told. One is what? 1 plus tau s by 1 plus alpha tau s. In this model I told one transfer function. The other way I told it what? 1 plus alpha tau s by 1 plus tau s. 2 models I told. This is also transfer function for lead you can take or lag you can take. This also you can take. The difference is alpha. So to get alpha directly, compare with this. If you compare directly alpha 3. Whenever alpha greater than 1 you are getting, simply pi m equal to sin inverse of, we need positive angle. Simply what? Alpha minus 1 by alpha plus 1. In case they given 3 in the denominator, compare with this. Use what? Sin inverse of 1 minus alpha by 1 plus alpha. So simply sin inverse of what you are getting? 3 minus 1, 2 by 4 means 1 by 2. Sin inverse of 1 by 2 means 30 degrees. Next, an amplifier with negative feedback overall gain is 100 and percentage, the percent change in gain with feedback, without feedback, 3%, 18. What is the feedback factor? So we can use the sensitivity here. STG equal to what? Percentage of change in overall transfer function by percentage of change in G equal to what? 1 by 1 plus GH. So what is the percentage of change in overall transfer function? 3% divided by 18% equal to what? 1 by 1 plus GH. Now this percentage cancel, 1 by 6 now here. So 1 by 6 equal to 1 by 1 plus GH. So that means what we are getting? 6 equal to 1 plus GH. So GH equal to 6 we are getting. But here they given what? Amplifier with overall gain given. It didn't give open loop gain. Overall gain is given. So we need to find what? Feedback factor means I need G. I need open loop gain. So for that use the what? Overall transfer function. Overall transfer function equal to what? G by 1 plus GH. How much overall gain or transfer function? 100 equal to G by 1 plus GH. What is GH? 6. GH equal to how much you are getting? 5 na? GH equal to 5. GH is here 5 because 1, 6, 1, 5 goes to here 5. So that means here GH is 5. GH is 5. Then you find G equal to 600. That means GH equal to 5. H equal to what? 5 by 600. You solve it, I think answer not matching 0.0833 or something you are getting. It is not matching any one of the option. Next, here they are asking, so here negative feedback. Steady state error for unit ramp input they are asking. Is given one is positive feedback, one is negative feedback. We know it for steady state error we required what? In case here negative consider, we should left with +1, you have to find with what? -1, because we required finally a equivalent diagram. Who it should be? Here this is summing point R, this is like G, C, here it is left with what? Unity negative feedback. So you write equivalent of G of S. What is G of S here? So first you write this. So what happened? Simple logic, 1 by S square into S plus 12. It is G of S. Opposite sign of the feedback, minus means here plus. Numerator is product with feedback gain, means 5 into S plus 1 divided by S plus 5. So this is up to this. Then you can simplify this, positive feedback left with what? Negative feedback. You simplify this because here minus is there, minus plus means you simplify, you left this because negative feedback should be left. It should be left with what? 1 with negative, 1 with negative, and here it should be 1. You simplify this also. If you simplify this, here minus plus, opposite sign means minus, numerator term means 1. That means what is G of S we are getting? Tell. S plus 5 divided by S plus 5 divided by, expand this here. If you expand this, S square into S plus 12 into S plus 5 plus 5 into S plus 5 minus S plus 5 minus S plus 5. Then if you write this, S plus 5 divided by, expand this, what you will get here? S square into, here S square plus 17S plus 60, yes or no, add and product. Then here S plus 1, this is S plus 1. So here 60 plus 5S plus 5 minus S minus 5. Then if you write G of S here, you will get it what? S plus 5 divided by, expand this, 1 minute, final answer I will write. You simplify this, you will get S into S cube plus 17S square plus 60S plus 4 you will get. H of S is 1. H is 1. So now steady state error for ramp input. Here type 1, this is type 1 system. It is a type 1. Type is 1. It is a type 1 system. It is a type 1. So steady state error A by K. A is 1. K is what? Numerator constant 5. Denominator constant 4. So 4 by 5 is the answer. Answer is 4 by 5. It is a, like we solved like these questions for steady state error to non-unity, adding one positive feedback, adding one negative feedback. Same thing. Here a typical root locus diagram shown where the system is critical damped. We know it, poles on real axis which are repeated. Here one pole coming, here one pole coming, repeated, and here at this point critical damped. That means B. At point B the system is critical damped. So for the system find initial and final value. You know initial value C naught. C naught equal to what? Limit S tends to infinity. S into C of S. So you solve it, limit S tends to infinity. S into C of S 10 into S minus 2 divided by, so S into S square plus 4S plus 5. So you solve this, what happened? SS cancel, S infinity denominator more means by default you will get 0. Yeah. no doubt initial value 0. Final value C of infinity, limit s tends to 0, s into C of s. But here you have to check the stability of the system. The given system is stable because final value theorem valid for only stable systems. So you can check the stability. So we can, it is a one pole at origin is there, it is allowed, simple pole at origin is allowed. This pole is in the left hand side, so system is stable, you can apply final value theorem. Simple pole at origin allowed for final value theorem. S into 10 s minus 2 divided by s square plus 4s plus 5. SS here, s is there. SS cancel. Substitute s tends to 0, 0, 0, 0. So what you are getting, tell, minus 20 by 5 means minus 4. That means 0 and minus 4. Next, what is the condition for critical damped? What is zeta, tell? Zeta equal to what? R by 2 root of C by L. Should be equal to 1, that's all. R by 2 root of C by L should be equal to 1. Answer is D. Electrical questions, very easy. Transfer function which just they are asking identify lead and lag. So C1 if you take, what is the pole location? Pole location minus 200. What is 0 location? Minus 3. That means it is a lead. It is a lead. C2 if you take, what is the pole location? Minus 3. What is 0 location? Minus 200. That means what it is? Lag. Lag. So that means answer A. Next, for the system stable negative feedback, so increases the feedback loops, the range of gain. See, as loops increases, for example, here R of S I'll take here some function like k by s into s plus 1 into s plus 2 you take. So then see here one feedback. First I'll take one feedback. We'll go on increase the feedback loops. Gain is going to be reduced. Range of k reduced. For example, first loop, if I write characteristic equation, expand this, s cube plus 3s square plus 2s plus k, first loop k. You find range of k, what you will get? Internal product 6 na? Internal range of k is greater than 0, less than 6. Range of k is 0, less than 6. Now one more loop if I put it here, then what happened? It will become 2k. Then what happened? Tell, 2k greater than 0, less than 6. That means k what happened? Greater than 0, less than 3. That means range of k is going to be what? Reduces. As the number of loops increases, the range of k for stability going to be reduced. This impulse response. What is the impulse response? So even this we solved in the class itself. What is C of S bar of S? 1 by 1 plus tau s. Simple impulse response means R of S is 1. So 1 by tau, take it common. So what I will get here? If you take tau common, what I will get? S plus 1 by tau. Apply ILT. If apply ILT, what I will get? C of t equal to what? 1 by tau into e power minus t by tau. 1 by tau into e power minus t by tau. Option A. Here see the transfer function of the system, how many roots lies in the right of the S plane for numerator and denominator. So numerator roots, see whenever question comes on the roots, there is no alternate other than RH criteria. It may be roots of numerator or it may be roots of denominator. Simply take the numerator term. First I will take numerator. So what happened? S cube plus 2s square plus 3s plus 1. I told it simply. What I told? Internal product greater than external means stable, no pole in the right. 6, 1 greater means no root right here. Stable means no root right. No root right. Simply denominator. Also check it. So S cube. If it is unstable, then again you can write Routh array. Again you can check it how many sign changes are. Here internal greater than external. That means here also what? No root right. Internal greater means no root right. So numerator also no root right. denominator also no root right. That means what is the correct answer? No root right. So that means 0, 0 is not there. So none of the above. Next. So a second order system as a pole, this is minus 1, this is not there. So minus 1 plus or minus J2 and 0 at 1. So that means what are the pole location mean? Minus 1 plus or minus J2 given and 0, this is pole, and 0 given at 1. And what is the transfer function if the steady state output and input to the step is, for step input steady state output should be 3. We want steady state output is 3. So simply write a transfer function tell. So I can say steady state output is k into what is the transfer function? One pole right mean 0 right na, because plus 1 given, s minus 1 divided by. So what is the equation for pole at minus 1 plus or minus J2 means s plus 1 whole square plus 2 square. That means what I can write? K into s minus 1 divided by s square plus 2s plus 5. So we want steady state output at where? 3, and CSS we want it 3 equal to what? Limit s tends to 0 s into C of s for step input. So that means k into s minus 1 by s square plus 2s plus 5 into 1 by s, because unit step ss cancel, s tends to 0 is substitute. So what is the answer you are getting tell? So 3 equal to minus k by 5. That means k equal to what? Minus 15. The minus 15, k equal to here minus 15. Minus 15, and the answer is B. Next. So here the transfer function of second order system, nature of the system. Simply nature you have to find. Omega n equal to what? Root 32. 2 zeta omega n equal to 15. So zeta equal to what? 15 by 2 into root 32. I think it is, if calculate it here, 1 minute. It is greater than 1 or less than 1, you have to find it. It is a what? 1.3 will get here. Means it is a what? Overdamped system. Next. So here S is not there. So a system having transfer function, time taken and TP you have to find it here. Omega n is 5 radians per second. Next 2 zeta omega n equal to 8. Then you find it here what? What is formula for TP? Pi by omega d you want it. So you have to find it here zeta value. Omega d equal to what? Omega n into root of 1 minus zeta square. So you find here zeta equal to what? 0.8. So that means here omega d equal to omega n is 5. Root of 1 minus 0.8 whole square. You solve it, you will get 3. You will get the 3. That means TP equal to what? TP equal to pi by 3. Answer is B. Not two questions. Which one of the following system is stable? Stable means roots must be real and negative. It should be negative roots. So then system is stable. Okay, na? Increase means wrong. Infinite means wrong. Yes or no? So transfer function natures. So which one is having underdamped system? So underdamped system, for example, you take here last one, if see omega n is 2. 2 zeta omega n equal to 3. Zeta equal to what? 3 by 4 means it is underdamped. Okay, thank you. So, the triple E questions more theory oriented are there as compared to the GATE. The questions are very easy. So, if you have any doubt, this is my contact number 98490 So, you can send in WhatsApp if you have any doubt. So, if you want still more all the questions, you send in WhatsApp, I will forward the questions. ISRO questions I will forward it, you can practice it. Thank you.